Hi guys, okay, let's continue our lecture. So if you recall, the last time we had our lessons, we stopped here. Now we're moving into the types of road construction. Okay, the first one you're looking at here, the first slide here is showing you the two typical pavements that we have. The one is a flexible pavement and the other is the rigid pavement. So as the name tells here, you will be able to imagine. Flexible means when the traffic load is traversing along the road, you come across movement that can rebound, right? The temporary aja macam elastik kalau bila tayar tu ada, dia akan turun ke bawah, bila tayar dah lepas dia akan melantun balik. Okay, whereas if it's a rigid pavement, then you can imagine such a movement will not take place. Okay, right, let's see. And the structure of these pavements are as such, you can see in the diagram here. So let's have a quick look through on the description given here. So for flexible pavement, the common term that we use is actually tar road, jalan tar lah, jalan yang hitam tu. Okay, and bitumen is widely used. Everybody knows bitumen is actually tar, and we have been using this for a long time. In fact, I have found historical evidence that since the Roman times, bitumen has been used, a form of bitumen, sticky stuff. That's why many of these remnants of the Roman roads are still remaining intact and can be found in parts of Europe, especially in the UK. Okay, as for rigid pavement, one of the typical characteristic of it is that it is very costly in the initial investment. You can imagine we are talking about concrete and reinforcement bars. However, in the long run, it is cheap because you don't need much maintenance. Okay, let's look at this. Take a look at the diagram here. Let's just look at the more common ones that we see first. That's a flexible pavement. You can see that at the bottom of it is of course a natural formation, and you learn in soil mechanics for any underlying ground, we need to make sure that it is strong and stiff enough. So this natural formation we're talking about in road construction, we call them the subgrade. You definitely will encounter that term in the JKR Arahan technique that I forwarded you. You should look through that. Alright, tak payah hafal ke apa, tapi at least go through lah. So in that sense, you can see that the original ground must be compacted, and if the original ground is not found to be suitable, katakan tanah gambut ke, tanah liat yang lembik ke, then it has to be improved. If it cannot be improved, then it has to be replaced. Okay, and next we come out the layer of what we call the sub base. Alright, and this is where you have larger stones, if you like, but in the road construction we call them aggregates actually. And the next layer up is the base course. Okay, followed by your binder course and the wearing course. So that is the surface and the surface dressing, obviously, that what they call the chips. Alright, a little, you can see these very fine chips bound by bitumen on road surface. That is what it is. Okay, let's take a look at the rigid pavement. It's a lot simpler, right? There are basically just three layers there. You have the subgrade coming up to your sub base. This is necessary to lay the foundation, the working platform for the road. And up there is just a concrete slab. There are no more layering at the top. Okay. Alright. Now, this slide gives you a very good overview on how a traffic load is being transferred into the road structure. If you take a look at the flexible one, you can see that, as I mentioned earlier in our lesson, the load on the flexible pavement is actually an elastic load, meaning that when the tire comes up, let's talk about just one tire. When the tire comes onto so in this sense, you can see that when the tire load comes onto the pavement at one single point, the pavement will actually slightly curve according to the load. Alright, and the load distribution pattern that we have is as such that it is a curve. It's almost like a parabolic plot, if you like. Can you see that? Okay, rather concentrated on that particular point. When the tire moves away, this load will be removed, and this part that has gone down just now will be rebound. Okay, that's the whole point of flexible pavement. You see, the thing with bitumen is that because the boiling point is rather low, if you have been in the lab, we have been able to do the test and experience yourself. But it's okay. If you come across a very hot day, midday especially noon time, 2.5 hari betul-betul panas tu, kalau you pergi kat luar jalan tar tu, you cuba cucuk tekan guna jari you aja. Cuba tekan kat jalan tar tu, permukaannya. You boleh rasa, dia boleh ditusuk punya. Especially yang baru, jalan yang baru letak tar tu. You cuba tekan, silap-silap jari boleh tembus. Macam tu. Sebab itu jalan tar yang baru letak tu memang mereka letak pengadaan tak bagi lalu punya. Kalau dia habis rosak. Sebab dia masih panas lagi. Bila dia panas, dia dalam keadaan yang sangat-sangat lembut. Okay, and that's why when it is already hardened, it will give you the flexibility there. Okay, now let's take a look at the rigid pavement. And rigid pavement, if you recall, is actually concrete. So kalau the concrete, you will bayangkan when the load comes across it, a single wheel, again we take the same example, the load will be distributed across a larger surface. Because why? Because it's rigid, stiff kan. Kita belajar dalam mekanik bahan, if a surface is stiff, a medium not a surface, a medium is stiff. When you have a load pop on it, it will tend to spread the load out over a bigger surface because it's stiff. It is not movable, it's not flexible. But if a surface or a medium is rather flexible or soft, when you put a load on it, it will actually curve. When it curves, it shows what? It shows that the load is concentrated on the most curved part. You bayangkan tilam, you bayangkan a mattress. When you jump on it, you see that only that point that you're jumping on is going down, right? It's curving down. When you jump away from it, it actually rebound and go back to the original condition, right? That is similar to the case of a flexible pavement. But you try to jump on the floor, normal floor, concrete floor, right? You won't see. You're not definitely going to see the flexible surface going down when you're jumping on it, and when you're off the surface, it is coming up. No, you can't see that. By right, yes, there's a very, very small, minute movement, but that is negligible compared to what we're seeing in the flexible bit. Okay, so I hope you get the concept there. Okay, let's move on. Now, we will go into how these roads these pavements are being constructed. Okay, first we look at the bituminous ones, which are the flexible pavement. Obviously, the flexible pavements are built very much using bitumen. That is a derivation from petroleum. It's a sticky, black, and highly viscous or semi-solid form of petroleum. Okay, it is cheap, hence we use a lot of it. To construct a standard bituminous road, you need 70% of bitumen, actually the raw materials you're talking about, and it works as a glue or binder that keep your aggregates together. So if you come to think about it, right, it's a very, very unique construction method and structure. You put loose rocks together, basically. As I said, the nama poyonya aggregate, sebenarnya batu aja lah. And it has to be, the standard says that it's granite. Why granite? Because granite is the hardest of them all. Alright? And bitumen is used in all situations when you have a bituminous surface, obviously, and it relies very much on its dense, stiff mortar for strength and stiffness. So as I said, when it is, that's why if you see in the road construction or road rehabilitation, when trying to repair a pothole or things like that, you see that they have a little trolley that and a tank that contains, if you like, melted bitumen. Okay, in room temperature it is actually semi-solid. You can still poke your finger in it, but when it's hot, obviously it's pourable. So in a small construction or small repair works, they usually just push a trolley with a tank on it, and the fire burning at the bottom. Is a very primitive thing, and they push it apart and need it, and just pour or just scoop it out and put it, and then they'll need to do compaction. Alright, and it's only when the bitumen is hardened, set and hardened, where the strength and stiffness will be obtained. Alright. Okay, and now we look more closely at the layerings of it. Again, as I said, you can see more of these the structural details of a flexible pavement in the Arahan Technique JKR. Actually there's an international standard for it, but each country will modify a bit to suit their situation. So in Malaysia, all roads, whether it's constructed by the government or private road, generally it will be constructed as per the Arahan Technique. Okay, So again, I repeat, bottom is your natural subgrade. It says natural here, but bear in mind that if the soil is bad, it got to be replaced, all right, or improved to become your compacted subgrade here. And the next layer is your granular subbase, come up to your unbound base, then only the parts that you need to put in the bitumen. All right, these are the what we call the surface layer, which consists of your binder layer and the wearing course or surface layer. Okay, different books may give you different names, but in general, this is the way we call them. All right. And the steps of constructing these roads, I think, is pretty straightforward. You got to prepare the base course. So now they go straight to tell you the subgrade is sorted out. You start the base course, lay the base course, put in the tar coat is a form of liquefied bitumen, lebih cair lah macam tu. Then you put in the premix, roll it, and that's about all. Okay, pretty straightforward. Now, in terms of constructing the flexible pavement, the method is very simple. The materials are also pretty common materials that we see. Now, then you may ask, is like, why is it that sometimes you see a new road being laid, but after a while, very quickly, within a few months, you can see the be having potholes and so on and so forth. We'll see later on that some of the failures that we usually see on this pavement, and after that, after this lesson, you should be able to speak more poyoli about the technical terms that we use to describe these failures. Okay. One of the problems that we encounter when we have flexible pavements that don't quite last is that the way we construct is not quite correct, especially in terms of what compaction. All right. If you recall, when we did soil mechanics, we talked about compaction as well. If you do not compact your loose material into the densest form possible, then you cannot expect to last, right? When you load it, lucky you have rainwater coming in. Water plus soil is never a good thing. Similarly here for the roads, water plus aggregates. Aggregates essentially is a form of soil, granular soil. What do you expect is going to happen? Okay, plus heavy roads, heavy traffic, heavy loading, right? So the failure is inevitable, if you like. Okay, this is important. Right? The advantages and disadvantages of having flexible pavement. In general, we can say that it is safe, it's durable, easy to construct, easy to maintain. It is a green pavement. Green probably you can say because now we are going to using RAP, recycle asphaltic pavement. So you do know that after a while, every road will need to be rehabilitated. So they actually scoop out the top layer. Essentially, they scoop out right down to the just before the base course, and then they mixed up again whatever that is broken up, add on with some new stuff, and then put in the bitumen and retie it and recompact it. So there's a little wastage there. So you could say it's going to green. However, bear in mind that because those things that you scoop out are actually old and used. So when it's old and used, and you mix with, say you use 60% of that because they're already broken, they lost their sharp edges for friction and all, and you add in with say 40% of the new stuff, it is definitely not going to be as good as it was in a situation where everything is new. Okay, so sometimes when we talk about using recycled stuff, you actually compromise a little on the quality. However, if the performance level is still within the stipulated standard, then why not? Okay, relatively is quiet. This is interesting. Low noise. You will fancy that if you drive along this kind of roads, there's barely any sound unless there's something wrong with your tires. The bunga kan, low cost and flexible new technologies and so on. What are the bad things about it? The disadvantages: less durable, less tensile strength than concrete, tendency to slick and soft in hot weather. See what I remember what I told you about. It's a very high temperature. It tends to want to melt, not exactly melting. Okay, soften itself, and then you feel that it may be sticky, especially when it's still new. Certain amount of hydrocarbon pollution to the soil and ground of waterways. This is interesting in terms of pollution. While the bituminous roads of flexible pavement have been around for so many years, thousands of years, and the technique has been perfected. Okay. However, in the past recent years, it has been found that they collected water sample from the roadside drains. Sebelah ini jalan tapi mesti ada longkang punya. You want because it's neighboring, you want to collect the surface runoff so that it doesn't bertakung kan, it doesn't collect and flood up your pavement. So they found that the water is collected there has got hydrocarbon contamination, and we do know that hydrocarbon means it derived from petroleum, and basically we are talking talking about stuff when you have carbon the element in your chemical compound. The tendency is that it goes into very long chain, and when it goes into very long chain, it's difficult to be digested and disintegrated in nature. And many of these are actually rather bad for plants, bad for animals, and bad for us human beings. So it is a concern to a certain extent. However, it is still, because look at the advantages of that, they are far more outweighing the disadvantages. Hence, some researchers will make some noise and say, you see, we found that it's bad and all, but then due to the advantages, especially the cost-wise and the ease of constructing it, is still being used a lot. Okay. Next, take a look at the concrete pavement or the rigid pavement. So these concrete surfaces, essentially imagine you're making a concrete slab, as easy as that. Okay, and we do know that concrete comes from limestone, and concrete roads have one very important characteristic, that is it has long service life. 40 years, that's a long time, and it does not require very frequent repair or patching work unless you have a big load falling onto the pavement and breaking it. There's a very small chance that the pavement will need any repairing or maintenance over the time. Alright, and it is also found that when traffic or a car is running along this concrete road, you actually consume 15 to 20% less fuel. And why is that so? It says here because there is no flexibility, right? So that if tak tenggelam, senang cakap kan, the tire doesn't tenggelam, maka you have less energy consumed. Alright, senang je, lancar je. I remember for every good there is always something. There's always what do we say? There's always two sides to a coin. So there'll be some problems, as we can see in the advantages and disadvantages after this. So the classification of it, we have several types here. You can see. The next slide will give you more details actually. Okay, these are the components structurally. We have seen this before. You need to have the subgrade, some drainage layer, subbase, and then you put in the pavement, the concrete slab. You can see that the structure is a lot simpler. Okay, I would like to draw your attention to this the structural component of a rigid pavement. Apart from all these terms in there, notice the joints. Longitudinal the joint, transverse joints, and also the dowel bars. So these are things that you will come across when you try to cast a big slab. As we all know, concrete will expand during the day because of high temperature, and during the night when it is cooler, it will shrink. So if you cast this piece of slab as one, you see that there will be a problem coming in. It will start to crack. You cannot be expanding and constricting. It's like expand, shrink repeatedly. Then the concrete will start to crack. Alright. And one more thing is that with concrete, is that when you are casting your concrete, we learn in the technology concrete. You cannot, for a big slab, for a big piece of element, you can't cast it at one go. Why? If it is so deep, when you cast it at one go, the ones at the bottom are actually starting to set, and the ones at the top are not doing anything and has just been poured, right? So when and the setting of concrete, which is because of the cement, is exothermic. Exothermic means what? Exothermic means it exudes heat, comes out with heat. So can you imagine when you pour your concrete first layer, and then you pour second layer, third layer, fourth layer, the bottom one is starting to be coming out with heat, but the top layer is actually, the second layer is actually preventing the heat from going out, and then the second layer will start to want to set and come up with heat some more. So the heat will accumulate and compound itself. So most likely your concrete form, especially at the bottom, is going to be weak. Why? Because the heat cannot be removed, funny chemical reactions will come in, and most likely the concrete, the bonds, in the structural bond of the concrete mass is going to be not as it's designed to be. Alright, if you're interested in this, you could actually just Google out a bit about pouring a large mass of concrete. For example, when we cast a rough foundation, so there is a technique in putting laying this concrete pavement, a big slab, and not just simply pouring it and leaving it to set as it is. Okay. Alright, I remember I told you that we talked about this earlier, about the types of concrete pavement. So now let's look at it. The jointed plain concrete pavement, this is the simplest. There's no reinforcement steel at all. It's just concrete slab. So we know that if it's a slab that has no reinforcement bars, that means the traffic expected to be going over it is not that dramatic. The second one is jointed reinforced concrete pavement. This has got steel bars in it at mid-height, just a single layer, and at the joints is discontinued. This is alright. And the third one is continuously reinforced. This is very costly. Throughout the stretch of the pavement, you have the steel bars in it. So that's why it's costly. And last but not least, this is a new innovation. We talk about pre-stressed concrete pavement. This is interesting. This could be more high, could have better performance than the counterparts because it's pre-stressed. So we do know that for pre-stressed, usually we find it on the flyovers for highways. Essentially, it's like Lego blocks. You put them on a string, on the cable tendon, on the tendon or cable, tendon, put them together loosely, then you tighten on both ends so they will come together tightly. So that is how it works. It's a very simple idea but brilliant to be applied in road construction. Okay, now we come on to the steps of constructing a concrete road. As you can look there, it's very similar to making a flexible pavement. It's just that you have situations where like formwork, joints, mixing and all, because you are going to make a concrete slab essentially. Okay, so tak payah hafal kan sebenarnya kalau faham. Now, look at the advantages. I would like to see the disadvantages as well. See, advantages and disadvantages. So obviously the disadvantages is far less compared to the advantages. So just a minute. Okay, so let's take a quick look at the advantages. Excellent smooth surface, smooth now. Deal with heavy traffic, concrete, no problem of sustaining bigger load. Lifespan is good stuff because it requires very little maintenance, so the maintenance cost is negligible. Long lifespan, heating is not done, blah 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 blah. So you can go through this. Handling, it says that handling of cement is easier than bitumen. In a way, true. Okay, it's true. And what about the disadvantages? Well, initial investment is very great. Every time you want to cast a big piece of reinforced concrete, it does require quite a bit of money. And the joints, remember I told you about the joints, longitudinal, traverse, and so the towers on the side. These are additional costs, additional elements that you need in the structure of a concrete pavement. And whenever you have such joints, obviously it's going to be the point of weaknesses. Okay, and you can't possibly do stage construction in this situation. When you cast it at one go. You can't do bit by bit. And with time, with the traffic traversing the road, you find that it will become smooth and too slippery. And the most common disadvantage of concrete pavement is the noise. You have come across stretches of these concrete parts, concrete segments in our highway. You see, they're very, very noisy. Extremely noisy. So this is where you think about the flexible pavement will absorb some of the friction and absorb some of the noise. That's why it takes away the annoyance of the buzzing sound. But with the concrete pavement, you do not have that. You just got to bear with it. Okay. Right. Now let's take a look at the defects and failures that we normally come across in these pavements. You have seen this before, and they are called alligator cracking. So masalah yang term ni, so masalah panggil alligator lah. Kalau Malaysian yang name it, probably kita panggil retak buaya kot lah. Alligator is a sharp nose crocodile in the States. So alligator is referring to the skin of the alligator here. Okay, next one here, if they are larger, they call them block cracking. Okay, and the bottom one here is a linear cracking or longitudinal, so right in the middle there. So this kind of situation most likely occur because these two sites were paved at a different time with different technology, different materials, different quality. Okay, similarly, this is a traverse one that is cutting across. It's like two parts are like breaking apart. Okay. You can have edge cracks. We also come across quite a bit of this in our own place. Alright. This is very commonly associated with slippage. You see, note the difference here. Edge cracks is longitudinal, they crack. Okay, but if a slippage is actually almost like a small slope failure, almost like because the road is an embankment anyway. So you can see that the slippage is like a curve, going to the side. So these are called slippage cracks. And you can have joint reflection cracks, such situations where the places where they start to rehabilitate the road, the joints are not properly done, you can have such cracks. Potholes, we like this. This is very common in our place. And whenever you have potholes, then we know that you cannot just pour in some new stuff and let it heal. No, it doesn't work like this. If it's a hole like this, they have to cut up a square of it, actually quite a big patch, and redo the portion. Then it will work. Now let's look at depression. So these are right in the middle of it, and you have a sunken bit, and you could have rutting. Rutting is also very common, a long stretch longitudinally, and you can see water collecting there. You can have shoving, and you notice this. Shoving is like the road is slanting to the side, and these are upheaval. This upheaval is not common. It happens like, you can see this is Masaleng's place. This situation most probably because of the frost. Yeah, it's heaving the mill. And if it is not due to the climate, because of the low temperature, it also could be due to the soil down there that is expensive. We learned it in some mechanics, tanah yang boleh kembang tu can also cause upheaval of the pavement. Okay, now we come to how to counter these defects and failures. Even right from the beginning, if your subgrade is no good, what are you going to do? And I can't improve it, too expensive to improve it, or I don't want to remove it and replace it with other stuff. So what do we do? So one very handy solution is what we call the geosynthetics technology. You must have come across geosynthetics. If any one of you attended the construction industrial week 2 weeks ago, where we have many industrial experts giving us talks, and you have listened to Dr. Lok from TENSA, you have seen about these geosynthetics, alright? So the functions of geotextile is one form of geosynthetics, okay? We use it in road construction for what purpose? As a separator, for reinforcement, for filtration, and also for surface protection. So it depends on what you want to do. They have different grades, different types to be used. Okay, and this is how they look like. Geotextile look like this. These are the woven ones. Macam anyam tika kan, you can see them very clearly woven. There are also the unwoven ones. When you look at it, it's like haphazard. The fibers are like haphazard. So those are usually used as separators in road construction. These are geocells. To say this is new, it's not exactly new, but relatively new compared to the geotextile and geograde. Geocell, can you see? It is actually collapsible. So when they deliver to site, it's easy. They just collapse it. So it's like piece by piece. And on site, they kangkangkan and bukakan. So these are very much used where? Yeah, right. You can imagine this is very much used in slope protection or slope stabilization on the surface, right? So they poke it on the surface of, not poke it lah, kena excavate sikit. So put it in there, and then put the soil in there, put the dowel in, keep them in place, and usually at the top of it, they're hydro-seeding. So over time, you have good plants, pakis, benda grow over it, you cannot see the geocell anymore. It is important to have coverage or covering for such for the geocell. Why? Because it is essentially plastic, geosynthetic. Plastic doesn't like what? UV. If you're exposed to the sun, very soon this will go kaput, repot-repot, rapot-rapot. Okay? And down here, we have what we call the geogrid. So geogrid was actually the focus of Dr. Lok's talk last week. So for this geogrid, as you can see, it is like a net. It's like a net. And in between, it will be where when you lay your aggregates, it will be interlocking in there. So, right? You can see it a bit more detail. Okay, this is how the geotextile will function. This is a pavement. Okay, this is the original ground. You can see it's a subgrade if you like. And the simple road, this is Jalan Kampung ni. There's a crushed aggregate layer, and immediately is the subgrade. So because the soil is bad, if you do not have any reinforcement, as you can see here, and you find that the unbound material, this crushed aggregate, will very easily be transferred, be forced into the weaker soil layer. It's only natural, right? You have two layers of stuff. The bottom one is weak, the top one are stones, for goodness sake. And you put a load. Of course, the top ones we want to go in underneath. Alright, kan dia flexible kan, katanya kan. But if you have geotextile, you see, is very effective in keeping these two fellas separated. You see? So that's the whole point of it. And in this situation, what we are seeing here is a wide zone of flexing caused by support of membrane across a crack. So if we have a membrane here, that's a geotextile, and having this separator, we could avoid this load to be transferred down to worsen the crack. So if we look through here, it says inhibit cracking of the pavement. The fabric bridges over cracks in the underlying pavement, preventing the cracks from being reflected in the overlying surface cause. The failure is at the bottom here. Alright, you don't want this cracking to be reflected up there. If you don't have this separator, this membrane here, what we call a membrane, this crack will propagate up there, isn't it? And eventually what will happen when it comes to the surface? Slowly it becomes a pothole. So that is what we don't want. Okay, this is if you look carefully, this is a road that is actually a rigid pavement, concrete, but at the top they want to make upper driving over it comfortable. They lay a thin layer of asphalt. Asphalt is bitumen, and they are very smart to put in a separator to avoid this from happening. And this probably is a low cost construction, so maybe the joints are not quite in place, or the joints are put further apart, and then the cracks can take place. Macam tu. Okay. Alright, here are the pictures of geotextile. You must have seen this a lot. Nampak tak? Si putih ni is a geotextile. These are the unwoven ones. Tak nampak pun. The lines macam anyam tika. Macam tak tempat ni. Piraja kan, our campus. This is F2 where they have the exams. Geotextile here. Why do they do this? And say, because in Piraja, our soil is very bad. We have soft marine clay kan. Right down to 70 meters is still the marine clay. This area, a long time ago, must have been the sea, or near the sea. Then tu lah. Okay. Again, can see those geotextile being put in place. These are geogrids. Look at the geogrids. Okay. So you can imagine when you have stones, aggregates in there, they will be interlocking between the space, between the geogrid netting. Okay. Now this is how they work. If you look carefully, again I said if you attended the lecture by Dr. Low, this will be easy peasy for you. Alright. When we talk about geogrid, there are essentially two functions of it. One, you want to have the confinement effect. That is to keep the stones in its place. Imagine I don't have this geogrid, right? There's no netting there. The stones are being laid around here in the layer. When you have a load coming in and the load is being transferred down to them, what will happen? They are loose. They are not bound by anything. They will start to want to move to the side, right? Especially your surrounding soil is pretty soft, it's pretty weak. So as time goes on, if more and more have gulling away to other places, surely up here you start to see an indentation. Betul? You start to settle down. And the second function of it is the tension membrane effect. This took them many years of research to come up to this. This is about reinforcing. This is about confinement. So reinforce means what? Like I said, when we mentioned earlier, when you have a geotextile layer separating two different materials, right? You find that when the load is being applied, the membrane or geotextile will take a lot of the load. So the amount of settlement that you expect will be far less. Not to mention this is actually separating the two different layers. Okay, so significantly it's going to improve your load bearing. There is a tension membrane effect. I like Dr. Loke's analogy. He referred to apa nama tu? Those just can't get it off the top of my head now. You put two poles up, you put a canvas in between, and you can lie down on it. What do we call that now? That kind of outdoor little bed, if you like. So yeah, so he referred to that. It's like when you go onto that, you put two poles. When you lie down on the canvas, the tension of the canvas is the one that's holding your weight. But if the poles are moving, is caving in because of your weight, then there's be less tension, and eventually your butt will be touching the ground. So that is the same situation here. Okay. So that's all for our lecture today. So it's 33 minutes. I'll upload it and you can get that. So don't forget to do your ulang kaji. Okay. Thank you. Bye bye.